So this is the solution for the MATLAB Octave Module 3 problem number 2. So for problem number 2, you were asked to calculate the horizontal and vertical distance as a function of time for a projectile that's being fired at 3 different angles. You were given an initial velocity, you were given the formulas, and you were given an incorrect value for gravity. So if you use the wrong value, that's fine. So I put this together here in the program. So you notice that the time was from 0 to 35 seconds. So that's the default increment of 1. We're going to have an array of 0 to 35 in 1. There's my initial velocity, 150 meters per second. There is the correct 9.81 meters per square second. Gravity, not the 8.81 that was given. And again, if you put that, that's fine. If you use the 8.81. In this case, just like Excel, all of your calculations, your trig calculations, are done in radians rather than in degrees. So the 90 degrees, the 45 degrees, and the 30 degrees that were given, you need to convert those to radians. You could do that within MATLAB, or you could do it outside of MATLAB. I chose to do it outside of MATLAB. You could use the radians function, the radians degrees function to change those. Or actually, degrees to radians, right? Functions to change those, but I have them here as already specified radians. Right down at the bottom here, I've got the plot for my 3 plots. The output asks for one to be solid, one dashed, and one dotted. I have the default for the first one, the 90-degree one, which will be a solid line. I have the dotted line, and that's the dashed line, and the dotted line. I have a title. Then I asked you to put a title, I asked you to put a legend. So my legend is going to be 90 degrees, 45 degrees, and 30 degrees based upon the way I have doing calculations. Horizontal distance on the x-axis and vertical distance on the y-axis. So I'll hit run. And of course, when I hit run, you'll see that the workspace has been populated. All the answers are here. Of course, what you can't see right at this moment is the plot, and I will show that to you here in a second. So when you run that program that I just showed you, this is the plot that will be generated. You can see that vertical distance is on the y, the label, horizontal distance is on the x. Horizontal versus vertical distance is my title, and you can see my legend there for 90 degrees, 45 degrees, and 30 degrees. What you might be asking is, where is the 90-degree plot? Well, if you can shoot a projectile straight up in the air, then you better run, right? It's right on the y-axis, so it goes up straight into the air, gravity overtakes it, and then it comes straight down. So you'll notice that there is actually a blue line if you look over here on the y-axis that goes straight up and comes straight down. You also notice that because of the time that we picked, we're going below the 0 point, right? If we drew the line out here for the 0 point, we would find the crossing, right? What's happening after the 0 point is you're going into negative vertical distances, right? So that would imply that the projectile is going down through the ground, which is possible, but probably not. I suppose if we were shooting these into a lake or some kind of body of water, right, it could still continue on it might still be able to continue on its path, and it would be below the ground in that particular case. But there you go. That is problem 2 from module number 3.